Hi, in this video we are going to talk about how to insert items into a B tree. So let's get started. As we have discussed earlier, one of the most popular B trees is the so-called 2-3 tree. What does it mean? It means that every node can contain at most 2 items or 2 keys, and every node can have at most 3 children. And this is the case here. We have the root node, the 17. It has 2 children. The right child contains 2 keys, and the right child of the node has 3 children. Okay, so this is a typical B tree, a so-called 2-3 tree. Okay, in this case, the m is equal to 2, which means that there can be 2 keys in the node. M plus 1 is equal to 3, which means that a node can have at most 3 children. And m divided by 2 is equal to 1, so this is the threshold. We have to merge 2 nodes together if the key number is less than 1. Okay, so basically we say that this m is the order of the tree. So in this situation, this is a second order B tree. Okay. So for example, we would like to insert some new items, and the simplest case is when there is no overflow, in the sense that we don't have to split nodes. Okay, so for example, let's insert 4. We start at the root node as usual for tree-like structures. We come to the conclusion that 4 is smaller than 17, so we go to the left. Okay, 4 is greater than 3, so we visit the right child. Okay, and here we come to the conclusion that 4 is smaller than 7, so we insert it to the left of the 7. Okay, and basically this is a second order B tree, so it is absolutely fine to store 2 items or 2 keys in the same node. In this case, this is a single node containing the 4 and the 7. Okay, let's insert 9. We start at the root node. 9 is smaller than 17, we go to the left. 9 is greater than 3, so we go to the right. And basically here we have to consider every item on a one-by-one basis. So whether 9 is greater than 4, yeah, we keep going. Whether 9 is greater than 7, yeah, we keep going. But there are no other items to be considered, so we insert it to be the right neighbor of the 7. Okay, you may come to the conclusion that it is approximately fine, but basically it violates the B tree principles. We have been discussing that this is a second order B tree, which means that every node can contain at most 2 items or 2 keys. But we have inserted the third item, this item 9, so we have to split this node. Okay, and basically this is the so-called split operation. We take the middle item, which is the 7, and we promote it to be the parent of this given node. Okay, so this is the so-called promotion phase, and we set the 9 to be the right child of this 7. And it is good. So this is how we insert a node when there's a single split. But sometimes when we promote a single node, there can be some overflow again, and we have to split the parents on a recursive manner. So for example, let's insert 11. We start at the root node. We go to the left. Okay, we consider 3. 11 is greater than 3, so we consider the next item. 11 is greater than 7, so we visit the right child. 11 is greater than 9, so we insert it to be the neighbor of 9. It's absolutely fine. 2 keys are absolutely fine for a second order B tree. What about we would like to insert 10? We start at the root node, we go to the left. Okay, 10 is greater than 3, so we visit the next neighbor. 10 is greater than 7, so we go to the right again. 10 is greater than 9, but it's smaller than 11, so we insert it here. It's very important that in a B tree, the nodes keys are in sorted order. So this is the right order, 9, 10, 11. it is forbidden to have the order, for example, 10, 9, 11. The nodes are absolutely sorted by the key values, whether they are strings, custom objects or integers. In this case, they are integers, so they are in numerical order. Okay, but we come to the conclusion that it violates the B-tree principles because there are 3 keys, 3 items in a single node, and we can have at most 2 items in a single node in this situation. So we promote the middle item, the 10, and we set the references accordingly. Okay, the right child of 10 will be the 11 and the left child of 10 will be 9. And it is absolutely fine because 9 is smaller than 10 but 11 is greater than 10. But you may come to the conclusion that okay, something is not good. It also violates the B-tree properties. First, because in the parent node we have 3 items and 3 keys and basically it is forbidden. And anyways, a node can have at most 3 children. In this case we have 4 children, so we have to split this node again. So we promote the middle item again and we set it to be one of the items in the root node. Okay, and of course we have to update the references, we just have to reorder, and basically this is how we solve this problem. So we have to call this insert method approximately in a recursive manner, which means that we have to check that whether promoting an item is not going to yield another overflow in another node. But basically we just have to promote the middle item, we just have to update the references, and basically that's it. And in this case it is a valid B-tree. It is balanced, so all of the leaf nodes are in the same level, all the left children are smaller, and all the right children are greater than the given keys. And of course, every node can contain at most 2 items, and every node can have at most 3 children. And basically, in this situation, for this B-tree, it's absolutely true. So this is how we insert items in a B-tree. Thanks for watching.